Hello class, in this video I will be applying the law of sines to find the missing side lengths and angles of a triangle. Let's begin. Solve the following triangle using the law of sines. Round answers to one decimal place. So I've already gone ahead and labeled all the given information in blue, and all of the information in red is what we need to find. And now that I have all of that labeled, I'm going to ask myself which geometric property of triangles is given. So it looks like there are two sides that are given and one non-included angle. So it looks like this is side angle, which means that either no triangle exists, one triangle exists, or two triangles exist. And we will determine which one here applies as we go through the problem. So with the given information, it appears that we have to find angle B first. So angle B, we can set up the law of sines as the following. And to isolate sine of B, I can multiply 2 times the sine of 50, like such. And we need to determine the value of B, so what I'm going to do is I'm going to take the inverse sine of both sides, or the arc sine of both sides. So angle B is equal to this expression right here. And you can evaluate that expression in Desmas. So I'm going to go over here into Desmas. I have the expression already typed in. Make sure you are in degrees. And remember to find the sines and the arc sines, go into functions, and then in the trig section you'll find your sine and your arc sine. So it looks like angle B is approximately 30.7 degrees. Okay, so what does that mean? Well, that means that we have at least one triangle. So here we have at least one triangle exists. Okay, so now that we know that at least one triangle exists, I'm going to label angle B, I'm going to label that angle B sub 1. For the first, meaning for the first triangle. And we are going to come back to this. But for now, we're going to finish solving for the first triangle. So we can now figure out what angle C1 is. So angle C sub 1. Angle C sub 1 is equal to 180 degrees minus the sum of the other two angles. So angle C sub 1 is equal to 180 minus 80.7. So angle C sub 1 is equal to 99.3 degrees. And finally, we can figure out what side C is now equal to. Actually, I'm going to write it over here to the side. I'm going to shrink this a little bit and write it to the side. side C. That is equal to the sine of 99.3 degrees divided by C. That is equal to sine of 50 degrees divided by 3. So after some cross multiplication, C is equal to 3 times the sine of 99.3 degrees divided by sine of 50 degrees. And again, we're going to go into Decimus to figure out that value. So it looks like side C is approximately 3.9. And this side length is the side length for the first triangle. Okay, so now we have the first triangle done. Well, what about the second triangle? Okay, so going back to the angle B. So is a second triangle possible? Okay, so going back to angle B1, that was approximately 30.7 degrees. So if I draw that angle, that is going to look like this, 30.7 degrees. And if I go into Decimus, the sine of 30.7 degrees is approximately 0.5105. Now, there is a second angle in quadrant 2 whose sine value is also 0.5105. And that is going to be this supplementary angle right here. So that is going to be 149.3 degrees. So the sine of 149.3 degrees is also approximately 0.5105. And I'm going to show you that right now. And there you go. The sine values are the same. So now what I'm going to do is I'm going to draw a triangle where angle B is 149.3 degrees, and then angle A is 50 degrees. And I want to ask myself, is that possible? The answer is no, because 149.3 plus 50 is equal to 199.3 degrees which is larger than 180 degrees. So in this case, only one triangle exists, and we are done.